Alright, we are asked to expand 2 plus root x raised to power 5 using the Pascal triangle. So I will quickly explain what a Pascal triangle is before we get into solving this question. Now, what is a Pascal triangle? Pascal triangle is actually an innovation that helps in the expansion of a binomial, right? Once we are presented with a binomial, we can implement the concept of Pascal triangle. Now, why is it called a triangle? Because the way it is being structured forms a triangle. These are sets of powers that in turn forms a triangle. For example, we have a number that a linear function that is just 1, a linear function. This is standing for a power of 0, right? So, but abstractly, most textbooks don't really put this, but there's an invisible 0 here, there's an invisible 0 here that we need to know in front of these numbers. Okay, so 1 plus this 0 here is 1. Can you see that? Then 1 plus this is 0 is 1. Don't worry, there's still an invisible 0 in front, in this front here, in this place here. There's still an invisible 0. So we will still say that. Let me put the 0 so you can understand how I'm getting all this stuff. So I will now have 1 plus this 0 is 1. 1 plus 1 is 2. Okay, 1 plus 1 is 2, and 1 plus this is 0 here is 1. There's still another 0, so you just keep having zeros in front, but we actually exempt those zeros so that we can have I will still give you a clear sheet of what this is. So 1 plus this is 0 is 1. 1 plus 2 is 3. 2 plus 1 is 3, and 1 plus this is 0 is 1. Okay, we still have those 0 in front. Just now there's an invisible 0 there. Okay, don't be carried away by some people like, where did you get this 0 from? There's a 0 there. So 1 plus 0 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 0 is 1. It goes on and on like that. Now, how do we know where to stop? This one here stands for any binomial with a power of 0. This one stands for with the power of 1, with the power of 2, with the power of 3, with the power of 4. So we are dealing with the power of 5. So we need to do one more. That means 1 plus that 0, I'll have 1. 1 plus 4, I'll have 5. 4 plus 6, I'll have 5. And 10, sorry. And 6 plus 4, I'll have 10. 4 plus 1, I'll have 5. 1 plus that 0, I'll have 1. So this stands for a binomial with the power of what? Of 5. So in this case, this is what we're going to be using in this question. I'm going to be using this particular one in this question. This is what we need. Okay? So in most cases or in most textbook, this is what you get to see. You just see 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You see the same thing with this one I just explained. I just explained how they got those 1 behind. That's why I added those zeros. Okay. So let's make use of this one I've outlined to solve what we need to solve. And mind you, if you notice something here, I have just one. I said with the power of 0, here, I have just one term. Right, this is representing a term. Power of 1, I have 2 terms. When somebody have power of 2, I have 3 terms. 1, 2, 3. Power of 3, I'm having 4 terms. 1, 2, 3, 4. 4, I'm having 5. 5, I have 6. That means whatever power you have, so the number of terms is equals to n plus 1. Suppose you have an expression x plus y raised to power n. So whatever that is in this power, add 1 to it. That will be the number of terms you have in that binomial. Just have to tell you that so you can be sure, because sometimes we need to have the idea of this when we are solving some questions. Okay, so I will leave this one because that's what we need for now. Now you still need to know that as this one decreases, this one increases. So you're going to start by, first of all, 2 raised to power 5. You start with that. Then root x raised to power 0. Make sure that when you plus the power of this one, when you plus the power of this one and the power of this one, they must be equal to this one here. So 5 plus 0 is still 5, so I'm not out of the box. So plus 2 raised to power 4. Now it has reduced by 1. That means root x will increase by what? By 1. Can you see that now? So you go in that manner. This one reduces to 3, this one increases to 2. Alright? Sorry. This one it increases to 2 like that. 2 raised to power 2, this one increases to what? Why am I writing this one? It increases to 3. Then 2 raised to power 1, this increases to what? 4. 2 raised to power 0, and I'll have this for 5. Okay? Now, I will still make use of this Pascal. Just follow me. 2 raised to power 5 in its own sense is 32. Right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That's 2 raised to power 5. And 2 raised to power 0 is 1. So this is 1. Plus 2 raised to power 4 is actually 16. Then n raised to power 1 will still give us back that number. Plus 2 raised to power 8 is 8. Then don't forget that this can cancel this one. So I'm having x here. Plus 2 raised to power 2 is 4. Alright, that's 4. Now this one is raised to power 3. That can be x root x. How did I get that? Let me quickly show you so it will not look like I just did a magic. You know, root x raised to power 3 can be written as root x raised to power 1 times root x raised to power 2. You know, 1 plus 2 is still 3. So this one normally cancels this one. So I'm having x left. So x with this with that's how I got this one. Okay. So that is very simple. Just basic mathematics. Okay. So same thing. 2 raised to power 1 is 2. 2 raised to power 1 is 2. Then this raised to power 4, that is s raised to power 2. Then 2 raised to power 0 is 1. Okay. Then this one raised to power 5 will be s squared root x. See what I just explained, you can know how to get that one. So 32 times 1 is 32 plus 16. Okay, we need to multiply all this by the Pascal. We need to multiply all this by the Pascal. How do we do that? There's 1 here. This 1 will come on this, multiply by this 1. This 5 we multiply by this 1. Just share it. 10. 10. This one will be 5, and this one will be 1. Right? Just share these guys into this expression. So 1 times 32 will give you 32. 5 times 16, that should be 90 with x. Yes, 90. 8 times 10 is 80 x plus 40 s root x plus 5 times 2 is 10x squared. Okay, then 1 times, so we still have this one back, s squared root x. So that just has to do binomial expansion of this manner. So in subsequent videos, you are going to see various forms where binomial questions can come out.